In this video, we'll be reviewing the basics of this unit, work and energy, for the quiz tomorrow. So I took two questions that we did in the homework. First one, Mike pulls a sled across a level of snow with a force of 225 newtons along a rope that is 35.0 degrees above the horizontal. If the sled moved a distance of 65.3 meters, how much work did Mike do? Well, we can start by drawing a diagram. Let's have this box here be the sled, and then there's this is the rope. It's at 35.0 degrees, and this is the direction of the force where it's being pulled. So to solve this, we need to split it into its components, x and y. Then let's also draw that it moves a distance of 65.3 meters. One second. Okay. Now, see that this is 35.0 degrees, and also that this force here is 225 newtons. Then we can call these other components Fx and Fy. So we're looking for work, so let's write out the formula. W equals F times D. Now we can't just multiply 225 by 65.3 because the vectors have to be parallel. So we can write these two lines to signify that they're parallel. So first, to find the work, we need to find the Fx, because that's the one that's parallel to the distance that was traveled by the sled. And to find that, we need to use, it's the adjacent of our angle, so we need to use cosine. So cosine 35.0 equals Fx over 225. Then we solve for Fx. Fx equals, I already wrote this down, 184.3092. And newtons to 3 sig figs. Now that we have this, we have the two parallel vectors, two parallel components, and we can just multiply them now. W equals F times D equals force, which is 184.3092 newtons, times the distance, which is 65.3 meters, and then this equals to sig figs rounded up. It is 1.20 times 10 exponent 4. Because it has sig fig on the 0, we need to write it in scientific notation, and it is joules. Okay, now next question. Pete slides a crate up a ramp at an angle of 30.0 degrees by exerting a 225 Newton force parallel to the ramp. The crate moves at a constant speed. The coefficient of friction is 0.28. How much work has been done when the crate is raised a vertical distance of 1.15 meters? Okay, so let's draw the diagram first. So here's the ramp. Let's extend it a bit. And it's at a right angle. So this here is 30 degrees. Then we know that this distance over here is 1.15 meters. And also, here I'll just draw a circle for the crate, is being pushed up with a force of 225 newtons. Okay, so we also have the coefficient of friction, but we can't put that in our diagram yet. We're looking for how much work has been done only vertically though, because that's the only distance it gives us. Or no, we're looking for it in total. Never mind. So we can start by finding the actual distance of the ramp. We have the angle and we have the opposite of the angle. So we use sine of 30.0 equals opposite over hypotenuse divided by, let's just call it h, I guess. H equals sine 30, 1.15 divided by sine 30. So that gives us 2.3. And now we just, well, actually I don't even think we need to use the coefficient of friction. We have the force, it's being pushed up. We have the distance, it's being pushed. So we just need to multiply the two. 2.3, let me write out the formula. W equals F times D equals F, which is 225 newtons, and which is multiplied by the distance, which is 2.3 meters. Oh, my bad. It's 2.30 meters. 3 sig figs. Let me just erase this part. 2.30 meters. So let's multiply this times 225 equals 517.5, so 518 rounded up. That is joules. Okay, and that's the final answer. So, yeah, let me know if you want another video, and good luck on the quiz tomorrow.